everyone, I'm Wei Fang and I would like to thank the MSPP 34th Scientific Meeting 2021 Committee for giving me the opportunity to present the findings from my research on the therapeutic potential of serum oxide nanoparticles in Alzheimer's disease. So Alzheimer's disease is a notorious disease whereby the patients will suffer from various debilitating symptoms such as memory loss, declining social ability, and worsening physical functionality. Globally, there are approximately 4.7 million people who are diagnosed with Alzheimer's. However, there are currently no definitive cure for this disease as all the available treatments can only assist in slowing down the manifestation of psychotic symptoms and cognitive deterioration. One of the primordial causes of Alzheimer's disease development is the presence of amyloid beta plaques in the brain. Excessive amyloid beta protein will promote the production of oxidative stress that further damages the nerve cells. Therefore, treatment that targets the amyloid beta protein and has antioxidant properties is ideal to hinder the advancements of Alzheimer's disease. Recently, serum oxide nanoparticles are being explored as a prospective medication to treat Alzheimer's disease due to their unique antioxidant capabilities. Serum is a D-block metal element that has two oxidation states. These rare earth metal oxide nanoparticles have a strong antioxidant profile because they are able to exert their enzymatic actions in both oxidation states to reduce the free radicals such as superoxide and hydrogen peroxide. They have been implicated in the treatment of several oxidative stress-related diseases, including cancer and diabetes, due to their unique antioxidant properties. Apart from that, serum oxide nanoparticles also have multiple biomedical and industrial applications, ranging from radiation shield in X-ray imaging, UV protection in sunscreens, catalytic converters of harmful gases, and fuel catalysts. Thus, we would like to investigate the therapeutic action of serum oxide nanoparticles in Alzheimer's disease models to affirm their potential as a medicinal element in treating Alzheimer's disease. We have conducted a systematic review to thoroughly research the role of serum oxide nanoparticles in Alzheimer's disease. We utilize databases such as PubMed, Medline, and Embase with keywords relevant to serum oxide nanoparticles and Alzheimer's disease to obtain papers that meet our inclusion criteria. After that, we extracted the results from the research articles and analyzed them to produce qualitative and quantitative data. This is the PRISMA 2009 flow diagram that summarized the search process and results we obtained from the databases. In the beginning, we identified 150 research articles, and after the abstract screening and going through the inclusion and exclusion criteria, only 17 papers are included in our systematic review. Based on our results, we found that serum oxide nanoparticles are able to exert various therapeutic effects in Alzheimer's disease models. In subjects that are induced with Alzheimer's disease, serum oxide nanoparticles are able to improve the cell viability, neuronal health, mitochondrial health, and spatial working memory. In addition, serum oxide nanoparticles also reduce amyloid beta aggregation, glial cell activation, oxidative and nitrosative stress, neuroinflammation, as well as neuronal apoptosis. Nevertheless, we also found that serum and serum oxide nanoparticles may cause toxicity in healthy subjects in Alzheimer's disease model in certain cases. For example, healthy CD1 mice that were fed with serum chloride experienced body and brain weight loss. They also had elevated apoptosis and oxidative stress biomarkers, as well as declining cell morphology and spatial working memory. Besides that, serum oxide nanoparticles treatment in healthy SHSY5Y cells and BV2 mouse experienced reduction in cell viability and increased neuroinflammation respectively. A slightly increased protein carbonylation was also observed when pregelated serum oxide nanoparticles were given intraperitoneally to Alzheimer's disease-induced rats. It has been demonstrated that serum oxide nanoparticles are competent against amyloid beta plaques and oxidative stress effects in Alzheimer's disease models. The nanoscopic size of serum oxide nanoparticles allow them to diffuse through the blood-brain barrier and employ its antioxidant effects on damaged nerve cells. The antioxidant action of serum oxide nanoparticles is alike to the biological antioxidants such as superoxide dismutase, catalase, and peroxidase. They also have a self-renewing antioxidant system due to their dual oxidation states, which is highly dependent on the pH and amount of substrates in the environment. A low pH would encourage serum oxide nanoparticles to act like an oxidant or produce additional free radicals. Besides that, a high ratio of either superoxide ion or hydrogen peroxide as a substrate will also cause reactive oxygen species amassment because of the serum 3+ and serum 4+ redox reactions. When superoxide ion reacts with serum 3+, hydrogen peroxide and serum 4+ will be produced. On the other hand, hydrogen peroxide will react with serum 4+ to produce superoxide ion and serum 3+. When either side of the redox reaction takes place more frequently than the other, the free radical product will pull up. This phenomenon may explain why in certain cases cerium or cerium oxide nanoparticles produce a toxic effect. So in conclusion, this systematic review has consolidated the therapeutic roles of cerium oxide nanoparticles in Alzheimer's disease models. Despite the setbacks of cerium oxide nanoparticles, their antioxidant properties are extremely favored to heal patients diagnosed with Alzheimer's disease. Therefore, a meticulous and exhaustive research should be carried out on the pharmacokinetics and pharmacodynamics of cerium oxide nanoparticles to obtain the optimum dose, dosage forms, and dosing frequencies while minimizing the events of toxicity. And these are the references that were used in this presentation. And that is all from me today. Thank you so much for your kind attention.